Hey there, this is a short video to talk about how crosswalks work as a way to compare two different zoning systems in GIS. We're going to use NHGIS data and crosswalks to do this, census data, National Historic GIS data, and do a quick kind of walkthrough of the whole process. So what are crosswalks? Crosswalks are a way to compare zonal systems. So you'll see here, for instance, this is really common with census data. Every 10 years, they revise the boundaries of census tracts, often subdividing them or just adjusting those boundaries. So you see here, we've got a 2010 census tract where there's two of them and they were combined in 2020, right? That would be an example of a situation where you need to have how many of the people in these two tracts ended up in this new tract if you wanted to compare population change, say, from 2010 to 2020. Often this is done through some kind of what's called aerial interpolation, and that is to say, imagine that we have zonal system blue, A, B, C, and D, and we want to take this population and calculate the population of this red square, which is some kind of different zonal system. Say we're comparing zip codes and census tracts, right? Something like that. What we would do would be, for instance, if 70% of this A square is inside the red square, we would multiply the population of area A by 0.7 and then say that was the population that falls in this overlap between the red square and the blue square A. In this case, that's a really simple way to do it. Often researchers will do things like look at the percentage of all the roads in area A that are in the red square, because that's a better proxy for things like population. These areas might have no people. Maybe they're mountainous. Maybe there's dragons there or something. It's not a suitable place, and so all the population would be in here, and roads would tell you more along those lines. Right, so that's one process. We're not going to go a lot into how that works because it can get a little complicated. But crosswalks provide the outcome of this. So this is crosswalks that are downloaded from NHGIS, which is a really nifty service that provides lots of different resources related to census data. One of those is these kinds of crosswalks. And we're comparing block groups from 2010 to block groups in 2020. And what we're saying here is that this census tract, basically the census tract 501001, block group. I use a lot of census tracts. This block group, 49% of the total population, this is a weight, so the weight for the population, 49% of the population of this tract from 2010 lives in this tract in 2020. Based on their calculations, so 501002. 501001 also has 51%, so basically it's split almost 50-50 between 501002 and 501003 in 2020. They basically kind of split it in half, right? And we can see similarly this block group that ends 002 is split 63 to 36 between these two block groups in 2020. And so we have these lovely little ratios here that allow us to do that calculation. So really what we can do is take, for instance, and I'll walk through this here in a second, we can take the population of this tract, and in this case we're looking at the number of people who are currently enrolled in an undergraduate program. Say there's 19 of those in 2010. If we wanted to know what that would look like for 2020 census boundaries. This is not saying how many were college students in 2020. It's saying how many, if we wanted to compare how many were in 2010 to the 2020 number, and we want to take these numbers and rezone them to fit these block groups, right? We would split this more or less in half, and we could do that using a join or a VLOOKUP function, and Excel would do that. So we would take the 19 and connect it here based on this. And I'll walk through how this works in a second. And then multiply these two numbers together. And so we end up with something that looks like this. So 19 times 0.49, so E2, which is this, times K2, which is this, the 19. So the weight times the population will give us the number. 51% times 19 is 9.6. 63% times 67 is 42. So this is the numbers that go with this. And you'll see down here, this one, 502,002, fits really perfectly, 100%, with 502,021. So all 47 of those people transfer over. All right. We would then use, say, pivot tables to aggregate them to the new 2020 boundaries. So let me walk through what this looks like in practice. Again, this is the same data you just saw. We're just going to actually do it as a live demo. See how this works. So here's those same boundaries, right? And I'm going to hide some of these. I don't want these two. This is just the regular old FIPS codes, so I'm going to hide those. I just want these GIS join fields that NHGIS uses. And I also don't care about some of these other weights. This is the percentage of adults or households or families, right? Or the area. That's that area weighting that we were just talking about. So I'll hide that too. And then I'll also pull in my census data. So this is 2010 census data, and it's on undergraduates. There's actually, they do school enrollment by gender, and so I had to add male and female together. But I'm just going to hide all these and just have that same GIS join field. I'm actually just going to delete this for the purposes of this. So this is my 2010 GIS join field. I'm going to copy these two and move it over here. So I've got my data all lined up. So here's my 2010 data, and here's my weights. To get the matching population for this 2010 tract, I just use VLOOKUP. So VLOOKUP. My reference, so the first thing, you need 4 things for VLOOKUP. The first thing is, what are you using? What's the value you're using to look up the match? It's this one, right? What's the range of the values that you're matching to? So it's this whole table. And the matching field in this table array is what it says here, always is going to be the first field. So you want to have the GIS join field be the first field here. And then I say, which column has the values that I want to add? And it's column 2. This is 1, this is 2. So I add 2, and then the last one's always going to be false. I want an exact match. I do that, and I get 19. If I copy that on down, you'll see it matches 1919, 67, 67 for 1002, 1002, etc., etc. And now it's really easy for me to just do the math. So this times this. And we've got the adjusted number. From this tract, 9.4 people live in, or sorry, this block group, 9.4 people live in this block group. Or 9.4 people would be in this block group were we using 2020 boundaries, right? Again, what we're trying to do is kind of change that 2010 data so we can look at it using 2020 boundaries. That's what we're trying to attempt here. Okay, so we've got that. Now what we need to do is we need to add up by these 2020 boundaries, because some of these are going to be listed more than once, right? So like 9502022 is listed twice here, and we want to add those values together. The easiest way to do that is to do a pivot table. I'm just going to do ugrad pop 20 here. So I've got ugrad pop 20 here. So we'll go ahead and do that. So I'm going to select this whole table, and I'm going to go insert a pivot table. And a pivot table is just Excel's way of aggregating, of doing summary statistics. And so what I want to use is my 2020 GIS join field, which is listed over here. These are all the fields that we saw over here. And then I want my ugrad pop 20. Now you'll see here what it'll do is automatically put it as like row labels. We don't want row labels. We want to add it up. And so we add it over to values, and it'll tell you how many entries there are because it says count. We want to change that to sum. So we go under value field settings and choose sum. And that will add up that value, right? So value field settings and then change it to a sum. So this is now the adjusted, these are the 2010 numbers, but aggregated using 2020 boundaries. I could then save this table, bring it into GIS, and join it to those 2020 boundaries and be able to compare the numbers in 2020 exactly to the numbers from 2010 using the same boundaries, do things like what's the change, etc. So this is kind of a quick walkthrough, and it's a little bit confusing, but it's a really valuable tool for being able to do some kind of historical demographic analysis, and I hope you find it helpful.